All right, we're going to continue working with this problem that we've started. We took our psychology original raw score, turned it into a z-score, turned it into a new raw score. We need to do the same with the biology, and then we're going to put it all into kind of a graph together and take a look at it another way. So for biology, it's the same thing. It's the same formula. Raw score is the mean plus z times your standard deviation. So again, raw score for biology is what we want. The new mean is 100. The z-score for the biology class was 0.75. Oops, 75. And the new standard deviation, again, is 10. So multiply your 10 times your 0.75, add that to your 100, and you should find that your new raw score for the biology class is 107.5. Notice that your position in the distribution here was higher than your distribution position in the distribution here. These have been put on the same scale already, so we can compare them. We couldn't do that with the raw scores, but we can compare here this distribution performance versus that one. And notice that in the final product, the psych score ends up higher than the biology score, 116 versus 107. So I really want to kind of cement this idea that we're really just relabeling distributions. Goes back to our characteristics, particularly the shape not changing. We could do this for either of those classes. We're just going to use the psych class as the example on this, or it'll get messy if we try to put both on there. So let's just consider the data that we were looking at from the psychology class. The original distribution we had up there said that for the original distribution, the mean was 50 and the standard deviation was 6. So we would be counting by sixes. So 56, oops, 62, 68, 44, 38, 32. Now, what was that raw score from the psych class, the original raw score? We said that was a raw score of 60. So where did that person's 60 land? Right there was their 60. About 1 2/3 of a standard deviation up. But then we turned that all into z-scores. We know z-scores have a mean of 0 and a standard deviation of 1. And remember, when we turned that raw score of 60 into a z-score, it was positive 1.67. Well, where is that? 1.67. It's in the same spot the 60 was. They're lining up. And then we turned it all into a brand new distribution with a mean of 100 and a standard deviation of 10. And when we did that conversion, we found that the new psych score was 116.70. Well, where is that? 100, 110, 120, too far? Oh, it's right about there. Notice that this person's position in the distribution is the same no matter which scale we were looking at, the original raw score, the z-scores, or the new converted, the new standard scale, if you will. They're all in the same spot. The shape of the distribution didn't change, and this person's position in that distribution was unchanged. They stay in the same spot. Again, the room didn't get hotter just because I converted to Fahrenheit. It just was a different number to represent it. Again, as a reminder, most of these I've used the population symbols as examples, but you could as examples. Sample notation could be used as well. Again, mathematically, they're interchangeable. It makes no difference whatsoever, really. Just denoting where did the data come from. That's all there is to Chapter 5. Those are our z-scores and our ways of working with them. So from here we go on to kind of Chapter 6 and 7 together, because we're only doing a little bit of 6 and a little bit of 7. We don't need all of 6 and all of 7 to accomplish what we need this semester. So we're just taking a handful of pages from chapter 6 and a handful of pages from chapter 7, and we'll put those all together in one sort of set of lessons. All right, we'll see you when we get to that.